Hi there, it's Mrs. Trembley again. It's time for lesson 1.4, multiplying integers. Yes, we have to know all four operations. So I'm guessing you know what that 1/5 will be about, division. But for today, we just need to talk about how to multiply integers. We're basically going to discover the rules based on some patterns, because I have found that if I just tell you the rules, it's difficult to remember them forever and ever. These are rules you have to remember, yes, forever and ever. So we're going to use a pattern to complete each table. The pattern that we're going to use on the left is different from the one on the right. So let's just start over here. Let's start with the top three because we know those. 2 times 2 is 4, and 1 times 2 is 2, and 0 times 2 is 0. But we have not yet learned how to multiply -1 by 2, or a -2 by 2, or a -3 by 2. So in here, there are some things you need to notice. In order for us to use a pattern to complete this, we have to notice things about the digits. First off, I'm hoping that you're seeing that in every single one of these, we're multiplying by 2, right? What's going on with the number that you start with, though? I go from 2 to 1 to 0 to -1 to -2, -3. Are you seeing that this digit goes down by 1 every single time? Okay, so that's what's happening here. So this is going down by 1 every single time, and I'm multiplying them all by 2. All I really need to do is continue the pattern in my answer to figure out these three. So if I go from 4 to 2 to 0, what's happening here? You're going down by 2 every time, right? So this one, as this is going down by 1, my solution is going down by 2. So down from 4 by 2 would be 2. And then if I move to the left in the number line again twice, I'm at 0. And if I'm at 0 and I move to the left twice, now I'm at -2. If I move 2 to the left from -2, I'm at -4. And if I move 2 to the left from -4, I'm now at -6. So that's one pattern. And we're going to use those in just a moment to answer these two problems. But now I'd like you to take a look at the right side of the table. In all of these, I have some positives and negatives in every single one of these. So in looking at this, there's none that we would probably know how to do right off the bat. We are going to use some patterns to help us with this. And notice in every single one of these, -3 stays the same, and these digits are also going down by 1, just like those were. So I think a long time ago you learned that multiplication and repeated addition mean the same thing. For example, if I said 2 times 3, that means that I have 2 3 times, right? So 2 times 3 could also mean 2 plus 2 plus 2, right? Because I have this 2 3 times. And 2 plus 2 plus 2 equals 6. I know that you already know that one. I'm just trying to use something that you already know to help you with something that you don't know. You know? Okay. So using this pattern here, we can do that to help us complete this table. If you have a -3 times 3, doesn't that mean that you have -3 3 times? So this technically means -3 plus another -3 plus another -3. -3 times 3 means the same thing as that. Now you've already learned how to add integers with like signs, right? When the signs are the same, you add the digits and you keep the sign. So a -3 plus another -3, that's -6. And a -6 plus a -3, that's -9. So -3 times 3 is -9. Let's use that same strategy here. I have -3 times 2. That means I have -3 twice. A -3 plus a -3, -6. If you have -3 one time, you just have -3. Now, are you seeing what's happening here in the solution? And this one, you might think, oh, it's going down by 3. Actually, if you moved on a number line from -9 to -6, you'd be heading to the right 3. So you're actually increasing it by 3 every time. So if you start at -3 and you increase that by 3, I would move 3 to the right, which would leave me at 0. And any number multiplied by 0 is 0, right? That's a multiplicative identity. Yep, we'll talk more about that, I promise. Okay, so now here I'm at 0. I'm supposed to move 3 again to the right. That would give me a +3 here. And if I move 3 again to the right, that would give me a +6. So this means that -3 times -1 is a +3, and a -3 times a -2 is a +6. Okay, how is all of this going to help us? Well, there's two basic parts, two truths to the laws for multiplication, the product rules. And basically what I'm hoping the first thing you'll see is that nothing has changed about how I get the digit. So if you just ignore the signs for now, 2 times 2 is 4, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. Those things are all still true, right? 3 times 2 is 6, 3 times 3 is 9. So nothing's changed about how we multiply the digits. You multiply the digits normally. The thing that's changed is knowing what sign to use. So it says here, the product of two integers with the same sign. So let's look for all of the ones with the same sign. Here's 2 positives, 2 positives. Here I have 2 negatives, 2 negatives. So all of those are the problems where I have 2 of the same sign. I either have 2 positives or 2 negatives. What kind of solution do you get when you have the same sign? Positive, right? So that's different than our rules for addition, because multiplication and addition are not the same exact thing. So the product of 2 integers with the same sign, it's always going to be positive. So that means if I have a positive times a positive, it's positive. If I have a negative times another negative, it's positive. Okay? What happens when you have 2 different signs? I'll do this one in green. So 2 different signs, a -1 times a +2, I got a -2. And here's 2 different signs, 2 different signs, 2 different signs, 2 different signs, and 2 different signs. In looking at this, every single answer is negative, correct? It's true. Now I know with addition, you learn that you take the sign of the greater digit, and that's how you determine it when you have one of each. 2 is greater than 1, right? But my answer is still negative. And this one I have the same exact digit, and the answer is negative. So does it matter which one's greater? With multiplication, it doesn't. When you have 2 different signs, no matter what, your answer is going to be negative. So same sign gives you a positive answer. Different signs, that's going to give you a negative answer. Always, no matter what. And if you multiply something by 0, you still get 0, no matter what you do. So with these ones, 0 times 2 is 0, -3 times 0 is 0. It doesn't matter what you multiply 0 by, it's always going to be 0. It's one of the nice ones. All right, so let's practice that. This would be the spot where you hit pause and you try some of these on your own, and then you unpause and see if you got them right. Welcome back. So let's see if you got it right. First off, nothing's changed about how we multiply the numbers. So 5 times 6, that's 30. And I learned that 2 of the same sign means positive. So negative times negative is a positive, so you should have 30 for that one. For this next one, yeah, when you have a number right next to parentheses, that means multiplication. So this does mean 3 times -4. And when you take 3 times 4, that gives you 12. When you have a positive times a negative, that gives you a negative. So you should have -12 for that one. The next one, 7 times 4 is 28. 1 of each means negative. 12 times 2 is 24. 1 of each, negative. 7 times 7 is 49. 2 of the same sign, positive. And the last one, I'm multiplying a number by 0, so it's 0. Please don't write -0. There is no such thing as -0. It does not exist. It's neutral. It's Switzerland. Okay, so just like when you were adding, you had more than 2 numbers to add, and when you're subtracting, you had more than 2 numbers. Generally in life, we have more than just 2 numbers. So I'd like you to know what to do when you have more than 2 integers that you're multiplying. Good news is that the commutative and associative properties that you learned for addition, they also work for multiplication. The order that you multiply 2 numbers doesn't matter, right? 3 times 4 is 12, and isn't 4 times 3 also 12? So if you're looking at the problems and you see, hey, these are all multiplication, it's great. You can mix up the order all you want. So commutative means you can actually move the number, and the associative property means you leave them where they're at, but decide to group them differently. So take a look at this first one. I want to multiply 2 by -3 by -4. With this one, I would use the associative property personally, and I would group -3 with -4 first. So that means I'm going to take 2 times the result of that. A negative times a negative is a positive, and 3 times 4 is 12. So I'm left with 2 times 12, which is 24. Now again, if you want, and I won't do this for every single one, just for a couple, if I wanted to just leave it alone and go left to right, 2 times negative 3, 2 times 3 is 6, a positive times a negative is a negative, would give me a negative 6. When you then multiply the 6 by the negative 4 that's left, 6 times 4 is 24, and a negative multiplied by another negative gives you a positive. So it truly doesn't matter what order you multiply them in. Do it in whatever order is easiest for you. So in the next one, I'll just go from left to right in this one. Why not? So this is associative, because I'm just leaving them alone and grouping these first. Negative 5 times negative 2, that's 10. And I still have to multiply that result by the negative 1 that's left. A positive times a negative is a negative. 10 times 1 is 10. Another little trick to this, whenever you multiply two negatives, you get a positive, right? So if you have an even number of negatives that you're multiplying, you'll end up with a positive result. Because if you can make a pair of negatives, you get a positive result. If you have an odd number of negatives that you're multiplying, you're going to get a negative result. Because the two negatives will give you the positive, and that extra negative that you multiply the positive by will always give you a negative. We'll talk more about that in class 2. Some of you will be like, what are you talking about? You'll see it more with the last 2 examples here too. Alright, the next problem here, whenever I see multiplication, and it's all multiplication, I look for the 0, because no matter what, if 0's in there and I'm finding a product, it's going to be 0. If you didn't notice that 0, then maybe you just went ahead and said, well, 6 times negative 11, 6 times 11 is 66, and a positive times a negative is a negative, and negative 66 times 0 is 0. You could have done that. You could have multiplied those two first and got 0 and said, well, 6 times 0 is 0. No matter which way you do it, you get 0. Okay, take a look at this next problem. And this is where understanding what I was talking about with an even number of negatives or an odd number of negatives can be helpful. If you wanted to just do this problem from left to right, I'll show you a couple different ways to do this. You could. Negative 1 times negative 1. That's a positive 1, right? And a positive 1 times a negative 1 is a negative 1. And a negative 1 times a negative 1 is a positive 1. And a positive 1 times a negative 1 is a negative 1. That's one way. You could also just choose to group these. A negative 1 times a negative 1 is 1. Negative 1 times negative 1 is 1. Multiplied by a negative 1. And then 1 times 1 is 1 times negative 1 is negative 1. I know. This all seems crazy, right? If you know that when you multiply 1 by itself, it's always going to be 1, that'll help you, for starters. Secondly, do you see how I can pair up these negatives to get a positive, those negatives to get a positive, and I'm left with one little negative left over? There's an odd number of negatives here. So if you know that when you have an odd number of negatives, you get a negative answer, and that when you repeatedly multiply 1, you get 1, you don't even have to really do anything. You can just say, well, when I multiply 1s, I get 1, and there's 1, 2, 3, 4, 5 negative 1, so that means it's negative. If you went from left to right, you'd end up getting the same result. It's just there are a few shortcuts. So let's try to use one of those shortcuts in this next one. I have a whole bunch of 2's that I'm multiplying. Do you see how there are an even number of negatives that I'm multiplying? That means my result is going to be positive. So you could just look at the digits if you want. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. It's positive because I'm multiplying an even number of negatives. You could also just group them like this. Oh, it looks kind of like little smiley faces, doesn't it? Negative 2 times another negative 2 gives me positive 4. Negative 2 times another negative 2 gives me positive 4. And 4 times 4 is 16. So there's all kinds of different ways to solve these. You do whatever's easiest for you. Using those commutative and associative properties are helpful. And understanding that an odd number of negatives when you multiply is going to give you a negative, and an even number of negatives is going to give you a positive. Those are all helpful things. Alright, we want to talk a little bit about exponents, so turn your page. And again, I'm asking you to evaluate, and hopefully we talked enough in class to understand that evaluate means you're solving it. So I want to know, what is the value of, and when a value is in parentheses, there's a fancy way to say it. You say the quantity of negative 2 squared. So if I want you to evaluate the quantity of negative 2 squared, the first thing you need to understand is this tells me how many of the base I have. And the base is just the number that you're raising to the power. So if I ask you to evaluate the quantity of negative 2 squared, that means you get to keep the negative with the 2. Okay? So this is my base, negative 2. This 2, small little teeny tiny 2, is an exponent. Don't call it little 2. It's a power. So second power, you could say, or squared, means I have 2 of this being multiplied. So this problem means I keep the negative with the 2, and I have 2 of them that I'm multiplying. A negative 2 multiplied by another negative 2. Same signs, multiply normally, and it's positive. So the quantity of negative 2 squared gives you a positive 4. Do you see how this one does not have parentheses around it? That's different. This isn't the quantity of negative 5 squared. This actually means the opposite of 5 squared. So if your base is not in parentheses, it's going to end up making a little bit of a difference. With this one, I kept the negative with the 2 because the parentheses forced me to do that. With this one, this means I want to do 5 squared, which means 5 times 5, right? This 2 tells me how many of the base I have. But I want the opposite of that. And we saw with absolute value, if I want the opposite of something, I put the negative sign outside of the brackets. Same kind of thing here. I want you to do 5 times 5 first, and then take the opposite of that. Anything in parentheses happens first. So 5 times 5 is 25, and the opposite of 25 is negative 25. So be very, very careful about parentheses. This is a big concept that you're going to talk a lot about in Algebra 1 next year. This is kind of like your introduction to it. So next one here. I have the quantity of negative 4 cubed, or raised to the 3rd power. Those parentheses tell me that the negative is going to stay with the 4. That means I want to multiply my negative 4 3 times. So there's a little teeny tiny exponent 3. That means I have 3 negative 4s that are being multiplied. So this one, I would just go from left to right. When you take a negative 4 multiplied by another negative 4, negative times a negative is positive, and 4 times 4 is 16. And I still now need to multiply that by one more negative 4, right? So when you take 16 and multiply it by a negative 4, some of you, when you look at this, you already know the answer is 64. If you don't, we know that a positive times a negative is a negative, and maybe you have to set it up like this, 16 times 4, and 6 times 4 is 24, and 4 times 1 is 4, plus 2 is 6. You could get it that way as well. If you didn't know what that was off the top of your head, that's fine. All right, and the last one, this isn't just exponents in there. There's a little bit more to it. Hopefully you're remembering with order of operations that you have to do exponents before you can do any multiplication. So we do need to fix this part up first before I can multiply by that 3. This is the quantity of negative 5 squared. That means I have the number negative 5 twice. Those parentheses keep the negative with it. And then I want to multiply that by 3. So, negative 5 multiplied by another negative 5. It's not 0, it's not negative 10. 5 times 5 is 25. A negative times a negative is a positive. So what I'm really asking you to do is to take 25 times 3. And if you have 3/4, you have 75 cents. You are all done. I'll see you tomorrow.